Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem number 287, find the duplicate number. So the problem says given an array of integers nums containing n plus 1 integers where each integer is in the range 1 to n inclusive. There is only one repeated number in nums. Return this repeated number. You must solve the problem without modifying the array nums and using only the constant extra space. Alright, so seeing the example 1 says that input is given, nums array is given, and elements just are from 1 to n, and there is just only one repeated element. We can see here 2, and all the elements are from 1 to n. Alright, so the repeated number is 2, so we can say this is 2. So the size of the nums array is, we can the nums in the question it is saying that integer nums containing n plus 1 integers. Total n plus 1 integers are there, size is n plus 1, so the elements are from 1 to n. 2 is repeated, so we have to return this 2. So what can be the most brute force approach? What do you think? I think that I can just solve this 1 2 2 3 4, and I can check in the next iteration which two adjacent elements are equal, and I will just return that element here. In this case is 2, and but sorting will take n log n time complexity. Space complexity is big O of 1 only, but in the question also it is told that we don't have to modify. So this is the brute force approach, okay, but it's not allowed. Now what can be the better approach? Let's think of it. Better approach can be, we can use a frequency array, or we can use uh, hash maps. We can use them for storing the count of elements. First we are here, we have got 1, so we have increased the count. Next 3, we have increased the count of 3. Earlier it was 0 in the map. Next 4, 1. Next 2, we have got this 1. Next we are here and we see that the count of this 2 is already greater than 0, so we can say that we have got this element before, so it's sure that it's only the duplicate element and we can return it. All right, so this can be the approach, but it will take big O of n extra space complexity also. Time complexity is also big O of n. Alright, but in the question it's again said that we have to do this in constant extra space. So what can be the approach now? So let's think of it. We have an approach, slow and fast pointer technique, that we also use in detecting cycle in the linked list. Let's see how can we use it. So when we use slow and fast pointers in linked list, we use just for detecting the cycle in the linked list. Can we uh, see that here the term is given duplicates? All right, so can we convert this question into a cycle? Can we convert this pattern into a cycle? Can we do this? So let's start from the starting. First we are here, let's go, and we are here, the first element is 1. Okay, first I should write the elements and their indexes 1 3 4 2 2, and their indexes are 0 1 2 3 4. So we are here first 1. Now from 1 where we can go? I mean, if we have to convert this into a cycle, I'm just doing that approach. I'm just going that direction, that way. So this is nums array. All right, this is nums array. So we have if the starting is 1 and nums of 1. Now if I talk about nums of 1, this one, nums of 1 is 3. So from 1 we are going 3. Now from nums of 3 we are going 2. All right, now from nums of 2 we are going 4. We are going 4. Now from nums of 4 we are going 2. So from nums of 4 we are going 2. So we can see that here we are repeating. We can see there is, this is the cycle, this is the cycle. Now from nums of 2 again we go 4. Now from nums of 4 again we go 2. We can see that we have got a cycle. So how can we do this? What's the slow and fast pointer technique? We all know that slow pointer moves by 1, and fast pointer moves forward by 2 jumps. All right, so if I draw this again, that was, I think, from 1 I was able to go to 3, and from 3 I was able to go to 2, if I'm not wrong, and from 2 I was able to go to 4, and from 4 again I was going to 2. Alright, so if we use a slow pointer and fast pointer at the very starting, that is 1. Alright, so and we keep moving slow and fast pointer until we get slow and fast pointer at the same indexes. So now let's move slow and fast pointer simultaneously, slow pointer by 1 jump and fast pointer by 2 jumps. So in the first, slow pointer will be here and fast pointer will be here. All right, now in the second iteration, slow pointer will be here and fast pointer will go by 2 jumps. So this will be here only, fast pointer will be here only. All right, so we can see slow and fast pointer are at 2, and we have seen that according to the slow and fast pointer rules, uh, first of all we have to start slow and fast pointer at the very starting index element. Then we have to keep moving slow and fast pointers, slow pointer by 1 and fast pointer by 2 jumps, and whenever they meet, if they meet at a point, it means the cycle is detected. It means there is a duplicate number here. All right, so there is a duplicate number here. This first case, when we see that slow and fast pointer is at the same position, now it's confirmed that there is a duplicate number or there is a cycle. Now what's that duplicate number? What we do in cycle detection? Now what we will do, we will declare a p pointer. Let's say p pointer, and we will initialize it at the first position. Now we will move p pointer by 1 jump and slow pointer by 1 jump from here only. All right, and now at the point they will meet, that will be only our duplicate number. All right, so in the first jump p will be here and slow pointer will be here. In the second jump p will be here and slow pointer will be here. So now we can see p pointer and slow pointers are at the same position. Now this position where p and s, p pointer and slow pointer are meeting, that's only our duplicate number, or we can say this is only the point where cycle is just started, or we can see where the number from where the cycle is detected. In the linked list also we have seen this. So all right, this is the logic. And so the first operation was to move slow and fast pointers according to their speeds, this by 1 jump and this by 2 jump, and whenever they meet at a same position, it means the cycle is there or duplicate number is there. Now for checking the number, exact number where the cycle is detected, where the duplicate number is situated, we have to again initialize a p pointer, and now we have to keep moving this p pointer and the slow pointer by one jump, both by one jump, and wherever they meet now, this will be this meeting point, or the element will be our duplicate number. All right, this will be our answer. So I'm not going to the mathematical proof here. If you want, I can create another lecture on the mathematical proof also. So if you want that mathematical proof now, you can just check on GFG or YouTube, or you can just simply Google it. There will be mathematical proof for about the slow and fast pointers, how they work. So if I go to the implementation part now, so what I told, first we have to declare slow and fast pointers. Slow pointer will be where? At the starting, and fast pointer will be where? It will be there in the starting. Now we have to keep moving it until in the first operation, until we find them at the same place. But we can see that in the starting they are already at the same place, so this will break our condition. So let's move the pointer by one. Nums slow is equals to nums of slow, and fast is equals to nums of fast. All right, now we will check if until we get the position where slow and fast are not equal, we will keep moving our slow and fast pointer. So slow will be nums of slow, and fast will be nums of fast. And whenever this while condition breaks, it means slow and fast pointer has met at a point. Now our first condition is first operation is completed, and when we are ready to declare a p pointer from starting index or elements from starting element, and we will keep moving the p pointer and the slow pointer until they meet at a point. And whenever they meet at a point, first let move this pointer. So p will be nums of p now, and slow will be nums of slow now. Now whenever they will meet, wherever they will meet, that will be our answer. Alright, so let's submit it and let's check whether we are able to pass the sample test cases. So yes, we are able to pass the sample test cases, and let's submit it and let's check whether we are able to pass all the test cases or not. So yes, we are able to pass all the test cases here, and we have solved this problem successfully. So what we learn from here? We learn about the slow and fast pointers, and how can we use this pattern slow and fast pointers in other questions. So this is a very standard question in the Striver's SDE sheet. So I have solved this, and you can also check the mathematical proof also on any website. And this question is very famous for checking the duplicates, or there are many other questions also, like happy number and other questions also. So this question is now solved. And yes, time and space complexity. So time complexity, we can say that this is just big of n, because no element is in the array, in the nums array is just we are using a while loop and another while loop. No element is just I can say is checked more than twice. Every element we are visiting at most twice. All right. So the time complexity is big O of n. Now space complexity, we are not using any extra space, so we can say that space complexity is big O of 1. So this is time and space complexity, and this is all about this problem. Till then, keep learning and keep upgrading yourself. Thanks for watching. See you in the next video.